Uh, Good evening, students. Today, basically, we would like to teach you the functions. Now, what is the functions that already you have learned in class 11? But what is the in relations and function already you have got a good concept in class 11. Still, just for the better recapitulations, just I am trying to reconnect you that when can we say a relation is a function? That means, first of all, we are accepting that a function is a relation. That's why I just see that I have written a statement. It is a very conceptual definition, not a book definition. This is what we understand functions. The function is conceptually a subset of relations. It is a subset sign. So a function is conceptually a subset of relations. This is the first conceptual definitions. But if you want a clear-cut definition, that if A and B are the two sets, then F is such that from A to B, from the set A to set B, suppose this is set A and this is set B, then a function is a relation, already I told, in which no two ordered pairs, this is very important line, no two ordered pairs have the same first component. It's a very technical definitions that you are supposed to know, but if I tell in this statement, maybe or may not be that you won't understand it. That's why, first of all, through mapping, let us understand that when can we say a relation is a function, and when can you say a relation is not a function. But all the relations are not functions. That is very important. All the relations are not functions, but all the functions are relations. And both are the concept of ordered pairs that we have to understand. Now, this is the suppose X. We generally consider X as a domain, that is autonomous variables, and Y generally called the dependent variable. Again, I will come to that concept whenever I will explain function in another way. But generally, in mathematics, we accept X as a autonomous variable or independent variable, and Y we generally accept as a dependent variable. Now, if X is here and Y is here, we have considered a concept of relations over here. See they have formed the order pair, that is the relationship. Relations it is made over here. Order pair 1, 3, then 2, 4, then 3, 5, and then 4, 6. So basically, I have already accepted that it is a relation. Now, under what concept these relations are a function? Can we say that this relation is a function? That is our first job. See, for being a functions, two important concepts we have to search. Two important concepts are what? Number one, all the domain, that is all the X elements has to be used up. So this is a very important thing, that the domain is supposed to be the domain is supposed to be entirely used up. If we see this, and if we can oversee over here, we can say it is the function. Another concept that is also important, that is each and every domain, each X of element, okay, should not have two or more than two images. These are called images. These are called the domain. Images actually called the range, already you know. Here it is called the domain. Now, as I say, that these two concepts will check If these two conditions are satisfied, we can say yes, the relation is also a function. Here you see all this 1, 2, 3, 4. This 1 has a corresponding image 3, 2 has a corresponding image 4, 3 has a corresponding image 5, and they have made the order pairs, and 4 also have the corresponding images 6, and thus they have formed these order pairs, and therefore we can say yes, it is also a function. Later on we'll explain that this type of function is known as 1-1 function. Again I will come back over here. Next you see second type of relation. Here also again I have seen a little bit different types of order pairs. Here actually 1 has formed with 3, 1, 3. So 2 also has images in 3. So 1, 3, 2, 3, and then 3, 4, and 4, 4, and these 5 things are not used up. Now the question is, this relation, can I say it's a relation? It's a relation. See, here whatever we are seeing, that these two conditions are getting satisfied or not. See, domain all the domain is entirely used up. See, 1, 2, 3, 4, all these X elements entirely has the corresponding images. Okay, entirely and each X of element or each X other element should not have 2 or more than 2 images. See, 1 has a single image, 2 also have a single image, 3 have a single image, 4 also have a single image. Maybe these 3 or 4 have the same images. That is possible. But each and every domain, each and every X should not have more than 2 or more than 2 images. That is, many one is not possible. Many one is a relation, but many one cannot be a function. So therefore, we can say yes, it is also this relation is also a function. It is a relation, and it is also a function. So this is a function we have understood. This is also a function we have understood. Let us come to the third mapping. Over here you see that here again in the mapping, 1 has the corresponding image 3, 2 has the corresponding image 4, 3 has the corresponding image 5. But you see, these 4 have no images. This 4 has no images. So since 4 has no images, therefore we cannot say that it is a relation. But this relation is not a function. So it is not a function. I made cross. Let us see the fourth mapping. In this fourth mapping, you see that this 1 has a corresponding image 3 and 1 also have a corresponding image 4. So a single domain, a single X1 have many images. So many images not possible. So this is also not a function. Baki hum log will not see whatever is there. But since I have one X have more than 2 images or 2 images or more than 2 images, then we can't say that relation is a function. Therefore, it is not a function. So it is a cross. So it's not a function. It's a relation but not function. Here you see another concept. Here each and every domain is used up, and each and every X has a corresponding images. But you just see this 7 is not used up like the previous one. But this is a function. This is actually we'll say it's an into function, or not subjective but into function. We'll explain it. This function, for example, is also called onto function. But when all the functions y is range are already have a corresponding f image or pre-image, then that function is called the subjective function. We'll come again whenever I teach you the types of function. I will explain that. But here you just see this 7 is not, though it is not used up, but still I can say it is a function. But it is a function and it is a onto function. Now it is not onto function; it is a into function. So in this way we can explain what or we can understand that what is a function. That is important. Once we understand that what is the functions, our next job will be the classification of functions that I will explain in my next class. Thank you. But today, up till now, we have just tried to reconnect you your previous syllabus of class 11. In the next class, I will teach you some different types of functions, the classification of functions. Over there, I will draw so many graphs so that you can understand, yes, this is the logarithm function, exponential functions. So my next video, I will basically try to explain the different types of functions over there. Okay, thank you very much.